So now, let's find the least common multiple. The least common multiple is similar to finding the greatest common factor, except instead of trying to find a factor that each and every term can be divided by, we're trying to find a multiple of these terms that can be divided by each and every term. So let's go ahead and do the example. Step 1 is to break each term into factors of prime numbers. Remember, prime numbers are numbers that can only be divided by 1 and that number. So 1's a prime number, 2's a prime number, 3's a prime number, 5, 7, 11, 13. You get the point? But we break it into prime numbers and multiples of each variable. So I'm just going to go ahead and do that. So 30 is 2 times 3 gives us 6 times 5 gives us 30. And then we have times x squared times y cubed. Then for our second term, we have over here, what's 42 divided by 2 gives us 21. What's 21 divided by 3 gives us 7. So that's 41 times x to the power of 3 times y squared. For our last one, we have what's 66 divided by 2 gives us 33. So 33 divided by 3 is 11. So now that's in prime numbers times x times y to the power of 3. The next step for this example is we have to take each individual prime number and variable, and for our least common multiple, we have to use the one with the highest exponent instead of the lowest. Greatest common factor used the lowest. This time we're going to use the highest. So let's start with 2. We have 2, the highest exponent of 2 is 1, and then 3, highest exponent of 3 is 1, and then we have 5, highest exponent of 5 is 1, and then we have 7, highest exponent of 7 is 1, and then we have 11, highest exponent of 11 is 1, and then we have our x, highest exponent of x gives us x squared. So that's the one we include. We always include the highest in least common multiple. For our y's, we have y to the power of 3. Anything higher? Nope. So our y to the power of 3 is the one included in the least common multiple. So you could go ahead and do this in your calculator. It should give you 2,310 times x squared times y to the power of 3. And that is your least common multiple for this example. In this example, we have two expressions that we are trying to find the least common multiple. The first thing we do when trying to find the least common multiple is we have to factor everything as much as possible. So you can basically break this into little problems in your head where we have some factoring problems and then we're finding the least common multiple as the final step. But let's just look at this first expression first. How can we factor it? Well, looks like we have a common factor of 4 that we can factor out. So let's do that. Let's write it as 4 times, let's see, how do we factor 4 out of this? 4a squared with the 4 factored out just gives us a squared minus a, right? If you factor the 4 out of that, and then minus what's 80 divided by 4 is 20. Now, can we factor this any further? Yep, we can factor the 4 into 2 squared, right? 2 squared. But now we can also factor this, right? Because it's a basic trinomial. So how do we do that? Well, we just need to find factors of 20 that will add up to give us our second term, right? So we have 20 times 1 And then we have 10 times 2, 5 times 4. Okay, there we go. Now that looks like something that will add up to give us negative a. So what do we need to do that? We need a negative 5 plus 4 will give us negative a. And if you multiply them, it'll give you negative 20. So yes, we can factor this. So let's go ahead and just bring this all down again. Don't forget the 2 squared. So 2 squared times, our factored form here is x minus 5 times x plus 4, right? Based on our factors that we found up here. Can we factor this anymore? No, we cannot. So let's kind of separate this in our mind, and let's work on this factoring problem. What can we factor out of here? Well, looks like we have a common factor, right? 2 can be divided from each term. So we'll go ahead and do that. 2 times a squared minus, if you factor out 2 from that, gives us 9a. And then if you factor 2 from that, gives us minus 10. Now, can we factor this? Well, let's see. If we do factors of 10, gives us 10 times 1, 5 times 2. And looks like 10 and 1 can give us 9. So how would we do that? We would do a negative 10, positive 1. That would give us both of these. So we can factor it. Let's go ahead and write this in our factored form. Don't forget the 2 on the outside. 2 times x minus 10 and x plus 1. If you'll notice, I've accidentally been writing our x's or our a's as x's, so I'm sorry for that. It's actually a. And so both of these are multiplied as much as possible. Now we can find the least common multiple. How we do that is we just take the highest exponent of each unique factor. So let's start with our 2. The highest exponent we have is 2 squared. So we will use the 2 squared for the least common multiple. 2 squared. And then our next unique factor is a minus 5. So our highest exponent of that is 1, so we can write this as a minus 5. Next unique factor is a plus 4. Any higher exponents? Nope. A plus 4. Then we have over here, we already did the 2. Now we have a minus 10 is a unique factor. Any higher exponents? No. So a minus 10. And then we have another unique factor, a plus 1. Any higher exponents? No. So a plus 1. Now, this here is our least common multiple for this example. Remember, if it's expressions, just focus on factoring them first. And then once you have them all the way factored into prime numbers and you've factored the remaining expressions as much as possible, finding the least common multiple just becomes taking the highest exponent of each unique factor.
Hey guys, if this video has been helpful to you, click the link in the description to get access to the complete Easy STEM Algebra 1 system, which includes a textbook, homework, and all of the course videos in order.